Okay, I'm going to go through the law of cosines. We do need to know, you don't need to know all three of these, but you do need to know the pattern. And we have to remember that when we go through this, the law of sines is used to solve triangles that are typically angle-angle side or angle-side-angle, and the law of cosines is required for side, 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 or side, angle, side. And when you have the ambiguous case, you're going to be using both. Okay? So now let's look at example 1. Here we have a side, angle, side. So if you look at it, we've got a triangle. They tell us that we have two sides and an angle in between. So I'm going to draw my triangle. And I am going to draw the C first. So I put the C here, and this is 20 degrees. And so opposite of this is C. Little c, we don't know what that is. I'm going to call this A. And that means this is 11. I'm going to call this B, and that means this is 5. All right, so that's what we have here. Now what we have to look at is, can this be a triangle first? So let's drop a perpendicular. And if I do the sine of 20, it's opposite over 5. And I am going to find what that equals. And if it is, if C ends up being less than that, we will be fine. All right, so now what I have is that H is 1.71. So C better be bigger than that, because H is our smallest side. So now I have to look for this little side. I have an angle in between, so I think I can use the law of cosines. Now remember, I'm looking for C, so C squared equals 5 squared plus 11 squared minus 2 times 5 times 11 times the cosine of 20 degrees. And I'm going to plug this into the calculator. I'm going to get 25 plus 121 minus 110 times the cosine of 20 degrees. And we're going to get a number that we're going to have to take the square root of. So I plug this in my calculator and I get C is 6.5, and it's definitely bigger than H, so we are okay. So that's one of the sides. Now I'm going to need to find an angle. I have a side and an angle, and I'm going to try and solve for B because it should be the smallest angle. So what I'm going to do is I'm going to use the law of sines. 20 is to 6.5 as the sine of B is to 5. Now I cross multiply, and since I'm looking for an angle, I want to put B is the inverse sine of 5 times the sine of 20 divided by 6.5. And when I put that in my calculator, when I plug this into my calculator, I get B to be 15.3 degrees. Now I have angle C and I have angle B. So what I need to find now is angle A, which is going to be 180 minus 15.3 minus 20. And when I plug this into my calculator, I'm going to get 144.7. And those are my answers. I have now solved for the entire triangle. Now what happens when I have side, side, side? Let's look at the next example. I'm given A, B, and C. These are all sides. And so what I've got here is let me make this A equals 9. Let's make this B equals 7. And let's make this C equals 5. And I need to find the angles. So let's pick a side. Which one I think we should go for the larger angle. Do you want to go for angle A because it's the opposite of the largest side? So using that, I'm going to say 9 squared equals 5 squared plus 7 squared minus 2 times 5 times 7 times the cosine of A. and I'm going to end up solving for A. So I'm going to actually take 81 equals 25 plus 49 minus 70 cosine A. 81 minus 25 minus 49 equals negative 70. And by the time I get this all by itself, I am going to get negative 7 over 10, which is negative 0.1. A is going to be the inverse cosine of negative 0.1, and I get about 95.7 degrees. Keep getting off the screen. Now I'm going to try for the next largest, which is angle B, and I'm going to still use the law of cosines. B equals 5 squared plus 9 squared minus 2 times 5 times 9 times the cosine of B. And so I've got 49 minus 25 minus 81 equals negative 90 cosine of B, and I'm going to get the cosine of B is going to be 57 over 90, and B is going to be the inverse cosine of 57 over 90. And what I get angle B to be is 50.7 degrees. They were given 3 sides, and I just now found 2 of the angles. How do you think we're going to find angle C? Angle C is just going to be 180 minus 95.7 minus 50.7, and I ran out of space. Angle C is 33.6. And I have solved this triangle. Now, solving triangles using the law of cosines is fine, and we can also now find the area of triangles. These are 3 different versions of finding the area. Basically, what you have here is that this is, it comes from 1/2 base times height, and these particular parts have to do with the height of the triangle. Let's look at this example. Finding the area of a regular polygon. Now remember, regular means that they're all equal sides and they all have equal angles, and an octagon happens to be 8-sided, and in this case the radius is 9. So I'm going to write down what I know. I have a radius of 9 and I have an 8-sided figure, and they're all equal sides, and I'm going to have 8 triangles from here. Okay? Now I know that the radius is 9, so every one of these legs are 9. All the way around is 360 degrees, and yet I've divided it into 8 sections, so that's 45 degrees. If I took one of the triangles, made it bigger, this is 45, this is 9, and this is 9. So now I need to find the area of this triangle. Now if I drop a perpendicular, that's my height, and I've got the angle in between. So if I want to find the area for this triangle, it's going to be 1/2, and I'm going to look at it and go, okay, this is 9 times 9 times the sine of 45 degrees. That's 1/2, 81, and this is the square root of 2 over 2. So the area of one of these triangles is going to be 81 square root of 2 over 4. That is the area of only one of my triangles. But how many do I have? I have 8 of them. So the total area is going to be 8 times one of my triangles, which happens to be 162 square root of 2, and this would be square inches. And if you put that into your calculator, you would end up with approximately 229 square inches is the total area. So all you have to do with a regular polygon is find one triangle and go from there. Now what happens if we don't have any angles? Heron's formula is what we're going to use. The semi-perimeter is just adding up all the sides of your triangle and dividing it by 2. That is your S. And then you just use this formula. It will be given to you. So we're going to find the area of this triangle. Let's look at the semi-perimeter. It's 13 plus 15 plus 18 divided by 2. Okay, well that's not too bad. What we end up with is that this is 23. Now to find the area, I'm going to take the square root, 23, 23 minus 13, 23 minus 15, and 23 minus 18. Put this into my calculator, and I get my area to be 20 square root of 23, which is about 96 units squared.